Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called SVS number 456. It's about Double-Decker Sandwich by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Clues on the left and above the grid are regular sandwich clues. That is, they indicate the sum of the digits that are placed between the digit 1 and the digit 9 in the corresponding row or column. So that would mean say we had a 1 and a 9 here. Then you would have to have a 4 in between because the sum of the digits between the 1 and the 9 for this column is a 4 because it's above the grid and it's to the left of the grid. So that means this signifies the digits between 1 and 9. This signifies the digits between 1 and 9, and so does this. Clues on the right and below the grid are also sandwich clues, but they indicate the sum of the digits placed between the digit 2 and the digit 8 in the corresponding row or column. So, for example, on this column, you have to have a 2 and a 1 between the 2 and the 8 because the digits between the 2 and the 8 sum to 1. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. For the 33 in row 1, between the 1 and 9 must be all the digits except 2. And the reason why you know that is if you subtract out 1 and 9 from the sum of the digits 1 through 9, which is 45, you get 35. Well, that means 33 of the digits, 33 of the sum, must still be within between the 1 and 9, which means the 2 has to be outside to add up to 35 with 33. And between this, we have 34, which means that between the 2 and the 8, which again, if you subtract that out from the sum of the digits from 1 through 9, you get 35. You have to have a 1 outside of the 2 or 8. So that means the 2 is on the outside, 2 is not between 1 and 9, and 1 is not between 2 and 8 here. So that means that you have to have a 1-2 pair on the outside. And they must be next to 8 or 9, right? Because the 1 and the 2 cannot be outside of the... have to be outside of the sandwich. Because otherwise it doesn't add up correctly. Well, if we had a 2 here, it would be outside of the sandwich from 1 through 9 here, but we know the sum adds up to specifically 2 for this pair. So this cannot be 2 here, it must be a 1, which makes that a 2. So between the 1 and the 9 have to be digits adding up to 33. So this is 9, which makes that an 8. So the normal sandwich clues will make red, and the 2 and the 8 crusts will make green. Everything else has to be not part of the crust. So this is 1. The sum between 1 and 9 in column 1 is 2. So this must be 2, which is a green. So that's 2, and this must be red and is 9. That means the remaining digits in the box cannot be 1, 2, 8, or 9. Between the 2 and the 8 must add up to 21. 21 minus 9 is guaranteed to be 12, so we have to have at least 2 other digits. So these are not green. Green could be here. You could have 3, 4, 5 with 8 there. So green is either here or here. Green cannot be either of these. And it can't be red either. Between the 2 and the 8 is 10. So this... you could have 2 digits adding up to 10. So this is not green. But it could be the red. Oh, this is 17. 2 has to be one of these 3. The 1 and the 9 are consecutive here. So 8 is one of these 2. You could have, again, 3, 4, 5 here. So it's 3, 4, 5, and this is 8, if that's the case. Or to add, for 2 digits, it has to be 5 and 7. And this is 8. So either way, we're guaranteed a 5 in one of these 3 cells. 3. So to add up to 3, you can't have 1 and 2 adding up to 3. It has to be just the 3 in between. So this cannot have a 3 outside of the sandwich. 3 has to be inside the sandwich here. This is 3, 4, 5, 6, 7. Again, 4 here has to be inside the sandwich. One has to be one of these 4 in column 3 because it must be between the 2 and the 8. And the 8, 2 or 8 cannot be here. You can have 3 digits adding up to 10 potentially here. Hmm. 23. So 2 is outside between the 1 and 9. We have 17 here between the 2 and the 8. And you can't have 9 in between. So to add up to 17, you have to have at least 3 digits in between the sandwich. So 2 cannot be here because that would guarantee 8's there. And at the most, which is 2 digits trying to add up to 17 without the 9 there. So 2 has to be one of these 2. 8 has to be one of these 2 because you have to have at least 3 digits in between to add up to 17. So one of these is 8. This is 2. This can't be 8, though, because if this is 8, this would not add up to 10 for a single digit. So 8 has to be here. So this is 8, this is 2. So this is green here and green here. And these 3 must add up to 17. So 1 cannot be in between them, because if 1 were in between them, the problem is... 1, 6, and 7 adds up to a maximum, of 14, which is too small. So 1 can't be here, which means these can't be green and they can't be red. So this must be the last red, which makes this a 1. So this is not 2 digits adding up to 10 because 1 and 9 would only add up to 10. So this must be another non-digit. Could be 9, actually. So it's blue or red. But then this has to be... Okay, it can't be 9 because that would be too big to add up to 10. So this is not red. This is blue. These are all blue because we have the red and the greens in the box. So this must be a combination of red and green. So this adds up to 17. 7 and 6 can be with 4. Or 7 and 5, 5 does not work. It has to be 4, 6, 7. So this is 4, 6, 7 as a triplet, which eliminates 4, 6, 7 in the rest of the row. So this is 3, 5 as a pair, which eliminates 3, 5 in the rest of the box. So this is 4, 6, 7. This adds up to 10 for 3 digits because it can't be 4. So it's either 1, 3, 6 or 1, 4, 5. We don't know which. This is 8, guaranteed. So there has to be 3 in between the 8 and the 2. Because we need... So this is 2. And this is 3, which eliminates 3 in the rest of the box. Therefore, to add up to 10, this can't be 6, because if that were 6 and 1, this would have to be 3. That's not allowed. 23 in between 2 and 8 in row 6. Well, 2 and 8 cannot be here. So... And it has to be at least 3 digits. Actually, it can't be 3 digits. If it's 3 digits, you have at most 6, 7, and 9 in between. So it has to be 4 digits in between, which means one of these is green, and then this is green, because none of these can be green. So this is 8 here. So this adds up to 21 between the 2 and the 8. So we have 9, and it's 5 and 7. This can't be 8. And this is blue. So this has to be 3, 4, and 6 outside. This is guaranteed to be a 2 then. So we have guaranteed 3 in between. That means the other 3 digits must add up to 20. Without an 8. So it could be 4, 7, 9. So we have guaranteed, it cannot be 1. So 1 can't be here. In addition, this can't be 2 or 8 here. If we had a 2 here, this could not be 8. So this can't be, this is all not green. So this must be red here, and this is green, green. So this is 2, 8 as a pair. This must be 1. So we have 2, 8 here and 2, 8 here. This can't, 6 can, well, 6 could be outside. Except, if you don't have, it's either 6 in between the sandwich or 1 and 5. But 1 has to be next to the 9. So, and you can't have 1 and 9, right? Because in between the 1 and 9 is 0, which means there are no digits in between the 1 and 9. So if you have 2 and 8 here, okay, so this can't be 2 or 8. It cannot be 9 either. So this cannot be, this is not 1 or 9. This is 2 and 8. It has to be next to a 6. Because if it's next to 1 and 5, the 1 would have to be next to the 9, which is not possible. So this is 2 and 8 here. That eliminates 6 from the rest of the box. Remaining digits in box 7 are 5, 7, 9, but obviously this can't be 9. That 5, 7, 9 triplet eliminates 5, 7, 9 in the rest of the column, so this can't be 5. This is 3, which makes this 5. No 7 here. Means the remaining digits in column 2 are, well, 2 can't be either of these, so this must be 2 here. And this has to be a 1, 9 pair. No, can't be 1, 9. We have a 9 guaranteed here. We don't know which it is. This is 4, 6 with 1. And this has to be 4, 6, 9, and 3. 3 can't be here because of 3 in the row, though. Between the 1 and the 9 is an 8 and something else. This is 1, 8, 9. Okay. Um, 23. Can it be 3 digits? No, because 9 is not included in the sum, and you only have 6, 8, and 9, so therefore this can't be 9, obviously. This can't be 9 either, so 9 has to be one of these two. Can it be the fourth one? I don't think so, right? Or this digit here. If this were 9, you'd have 5 digits trying to add up to 23 with an 8 in between. But that would mean these two digits would... Okay, so outside of the 1 and 9 has to add up to 35 minus 23, which is 12. Well, this then has to be outside because this is 7 at most. This is red and is 9, which means this cannot be 9 here, which means where is 9? This is blue. This has to be a 9 in box 7. So these must add up to 19. It's at least 3 digits, so 1 can't be here. 1 could be for after 3 digits. So this is 9. 2, 3, and 7 add up to 12. 2, 4, and 6 add up to 12. 2, 5, and 5 would add up to 12, so this can't be 5, that can't be 4. So in this 6 eliminates 6 here. So this is 7. So 2, 3, and 7 are outside of the 1, 9 sandwich. 1, 3, and 6 add up to 10 inside the 2, 8 sandwich. So this must be 4, 5 as a pair. So 4, 5, and 6 add up to 15, plus 8 is 23. So that satisfies that. 7 eliminates 7 here. So this is 5, which makes this 7. Six eliminates 6 in the rest of the column. 3 eliminates 3 in the rest of the box. This has to be 4, 5, 6, 7. Where is the 5 in row 2? It must be one of these two digits. So therefore this cannot be 5 here. $20 between the 1 and 9. Well, 20, to add up to 20, 1 and 9 cannot be here. To add up to 20, if you don't include the 2, it would be only 2 digits, which is too small. So it has to include the 2. So this is 1 out of 1 or 9. 2 plus 3 digits must add up to 20 because 2 digits can add up to at most 17. 2 plus 17 is only 19. So this is blue because it cannot be another 1, 9. These are both blue, and this must be red. And this cannot be 9, it's 1. 8 cannot be here, so 8 has to be one of these two. So this is blue and green as a pair. This has to be 9 because there's no other place for it. So these add up to 20, so it's 2, 8, and we have to have a 3 here, so it's 3 and 7. And 3 cannot be here, so this must be 7, and it can't be 8 here because of 8 in the box. So this is 3, 8 as a pair. That 7 eliminates 7 in the rest of the column, so we have a 4, 5, 6 triplet, which eliminates 4, 5, 6 in the rest of the box. So this can't be 4, 5, or 6, it's 7. Which eliminates 7 in the row. So this must be 4, 6 as a pair, which eliminates 4 and 6 in the rest of the row. So this can't be 4 or 6, it's 5. Okay. If we had... Well, 1 can't be here, so this cannot be blue. Therefore, this can't be green. So this must be red. I guess this could still be green, technically. This is blue or green here. This can't be green because of the double greens in the row. That means this is red and is 9, which makes this 1 here. This adds up to 19. Can you have it with 2? 2, 7, 8 adds up to 17 at most, so this can't be 2. This is 8, which makes this 2, which makes that 8. Which eliminates 8 here, so this must be not a green, it's red. So that must have a 4 next to it, which makes this the other red, and it cannot be 9, so this is 1, which makes that 9, so this can't be 9, this can't be 9. 8 eliminates 8 here, so it's 3, which makes this 8, so this is not green, that's blue, this is not blue, that's green. 2 cannot be here, so where's 2 in row 7? It has to be here. So this is green, which means this can't be green there. This is 2. One of these is 1. This can't be 1. So this can't be 1, cannot be 2, 8, or 9, so this is definitely blue, which makes this red and is 1. That makes this 4 or 5 here. 3 eliminates 3 here. You're guaranteed a 7 here. So it must be 4, 7, and 8 adding up to 19, which eliminates 4 in the rest of the row, so this can't be 4, it's 5, which makes this 4, which makes this 5. 4, 7 pair eliminates 4 here, so it's 6, which means this can't be 6. 4 here eliminates 4 here, so it's 6 and 4. 4 and 6 eliminate 4 and 6 here, so it's 7. So there's no 4 or 7 here. 4 eliminates 4 here, so that's 7, which makes that 4. 4 and 3, 5, 6 eliminate 4 and 6 here, so it's 7. 4 eliminates 4 here, and this 1 eliminates 1 here, so this is 6. That makes this 4, which makes that 1. So this is the red. This is blue. That means this can't be 6 here. So this is 3, 4, and 9. This can't be 9. So one of these is the red one. This can't be 1, 2, 4, or 9. So that's none of them. 4 eliminates 4 here. So that's 3 or 9. 2 can't be here, and it can't be 1, 8, and 9, so this is blue. 1 eliminates 1 here, so this is 8, which makes this 1. Not red. This is green. This is not green, so it's red. We have all the crusts in column 6, so this is all blue. This can't be 2 in column We have a 2 remaining in column 5. It has to only be here, which makes this blue. 8 can't be here. This can't be 1 or 9. And we can't... Where is the 8? 5 eliminates 5 here, so this is 7, which makes this 5. This can only be the 8, so this is the green and 8. This is 3, 4 as a pair. This can't be 1, 2, 8, or 9, so that's blue. Okay, so let's double check. Everything but the 2 is inside the 1, 9 pair. That's 35 minus 2, which is 33. Everything but the 1 is out in between the 2 and the 8, so it's 34. 2 is between the 1 and 9, so that's satisfied there. 4 is between the 1 and 9, that's satisfied there. 2, 3, 7, 8 adds up to 20, which is between 1 and 9 here. 4, 5, 6, and 8 add up to 23, which is between the 1 and 9 here. 2 and 8, between the 2 and 8 is 4, 6, 7, which adds up to 17. Between the 2 and 8 is 3, which adds up to 3. Between the 2 and 8, this adds up to 12, which it does. And we have 6, 3, 5, and 9. So 3 and 6 add up to 9, plus 9 is 18, plus 5 is 23. This can't be 9 because of 9 in the column. Between the 6 here, that works. This cannot be 3. This is 3 or 4 left in row 9. So this can't be 3 because of 3 in the box. So this is 4, which makes this 3, which makes that 4. That's 3 in the corner. We celebrate because we're close to solving it. This 4 eliminates 4 here, so that's 6. This is left here is a 6. Remaining digits in row 8 are 3 and 5. We have a 3, 5 pair in column 4, which eliminates 3 and 5 in the rest of the column. This can't be 3 or 5. It's 9 and is a red. So that makes this blue. That eliminates red from being here, so that's blue, which means this can't be blue. It's red. So that's 9. This is 3. This is 4, which eliminates 4 here. So it's 3, which eliminates 3 here. So it's 5 and 3. 3 and 5 eliminate 3 and 5 here. So it's 6. 3 eliminates 3 here. So it's 5. This can't be 5 or 6. It's 3, which forces this to be 5. That leaves the remaining digit here as a 7. This digit is a 6. And this digit is a 4. And that's how you solve this puzzle. Yeah, fairly straightforward. I haven't done any sandwiches with between 2 and 8. I think this is the first one. And so this is kind of interesting in noticing the interactions between the sandwiches of 1, 9 and the sandwich of 2, 8. But not too bad. It's pretty straightforward to solve this. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.